In this video I want to explain how to develop a ray tracer using test-driven development. I will not start from scratch here. Instead, my plan is to add to an existing ray tracer a new feature. The ray tracer I'm going to extend is a special one. It only works in 2 dimensions. Here on the screen you can already see a rendered scene of my ray tracer. It shows an orange color a ray and in blue color the Stanford bunny. Just in the case you don't know, the Stanford bunny is a famous 3D model that is used in many 3D applications as a test model. Rendering works by handing over a scene file to Flatland. Flatland is the name I have chosen for my 2D renderer. Here in the command line you can see also some magic. It's Bazel magic. Bazel is a build system developed by Google and I use it to build my 2D ray tracer. Now I hit enter and then from the scene description a SVG file gets generated. If you take a look on it, we see the Stanford bunny here. That is described in the scene file format. Now let's look in more detail at the scene description. We have here a camera description and also the description of a shape. And for the shape we have a polygon, and the polygon is referencing to the vertices of the Stanford bunny. I have created a 2D version of the Stanford bunny. Here you can see the different vertices that make up the Stanford bunny. The scene file format was heavily influenced by Mitsuba, an advanced educational ray tracer. Instead of influenced, one can also say shamelessly stolen. In the case you want to know how the file format works, just take a look on the documentation of Mitsuba. The Stanford bunny looks a bit small, so I want to scale it. And that's exactly where the implementation of a new feature begins. Currently scaling is not supported in my ray tracer, and doing it in a test-driven way, we would just first do it from the perspective of a user and then write the test. To do scaling, I just add here a scaling transform, scale. Let it be 3 times bigger. And then we just re-render the scene again. Then render it again. Now let's get back to our folder, open the output again. Oh, it didn't scale. Scaling is currently not implemented. This is now where the fun part begins. We first write the test for scaling. Given this file, I would expect when I read it that the polygon has a transform that is composed of the scaling and translation. Let's implement a test for this. Oh, I just noticed I did a small error here. We just work in 2 dimensions, so I don't need the set component here. Okay, where's a proper place to implement our test? I have already some tests for testing scenes and for loading scenes, and one test I have already in place is this read camera transform test, and it loads some scene file and then checks the camera transform. And we can do the same in a similar way for the polygon. Now let's start with it. So I start just to copy that one and then I will do some renaming of it. Scene read polygon transform. Then we will read the bunny file. Then we will look for polygon, and as a chart it's the transform. Then we read it, and then we have some expectations on that one, and we can simply say, okay, matrix since I don't want to bore you, I skipped implementation, and now here's my final test. It computes, or it sets up the scaling matrix, then the translation matrix, it makes the multiplication of both, and then we have our expected result, and then this result is compared to the transform that is read from the bunny file. If we run the test, it is red. Yeah. This is not surprising, since we just implemented the test. Now the next step is to get the test green. I just recognized that I did my scaling in the wrong way. So we have to change this here in this scale matrix to 3. The same way it is in the file. Just to avoid some surprisings regarding this multiplication, we can also add a test for that one. I just copied this code here to my matrix test. It is here. Just create a new test. Here's the finished test, and we can just run it, and yeah, it works. The multiplication of these two matrices gives this result here. Now I'm going to make this test green. I go to my retransform function, take a look at it. I think I'm done with it. Unfortunately, here I noticed that this multiplication does not work. Now we have to implement it. Before we implement it, we have to write a test for it. So this is a multiplication between two transforms. So the transform is of type transform, and also the scale function returns a transform. Then let's go to the test for our transform, and let's implement a multiplication test. I'm done now with the implementation of the test. Now let's implement the multiplication for transforms. I have detected an error here. I had to switch translation and scaling because I want to first scale and then translate. And now the test works. Now we can go back to our test scene test and then test our read polygon transform again. It was still failing, and the reason was that this initial setup here, I was reading the wrong transform, the wrong XML elements, and now it's fixed. And now if I re-execute the test, it succeeds. Do it once again, yeah. Reading the transform from an XML file seems to work, but does it also work when we read a scene file? Now let's re-render again. Then we take a look at the generated file. And now finally it works. Great.